One of the things we don't talk about very much in mathematics is some of the really basic curves. What you're really curious about is how much area is underneath them. So, for instance, how much area is under the x squared term curve from 0 to 2, or from 1 to 2, or from 1 to 3. You know, how much area is under this curve? Well, it's really hard to give an exact answer to that. But I can give you an approximate answer as long as I'm willing to use rectangles. Rectangles are easy to approximate. Just to make it clear that we're not having to start at the origin, let's go 1 to 3. What if I used 4 rectangles and I said, well, that rectangle's about close, that rectangle's about close, that rectangle's about close, and that rectangle is about close. Well, if I summed up the area of those rectangles and I estimated that, that would be called a left-hand Riemann sum. With 4 rectangles. And some people abbreviate that L4. Okay, so left-hand Riemann sum, 4 rectangles. And you could sort of calculate out that essentially if you called this point A and that point B, then you would have some delta x that would be dividing, right, B minus A divided by the number of rectangles. So in our case, it would be 3 minus 1 divided by 4. The rectangles would each have a width of 1/2. And then we could take the height at each point. In our case, maybe what we do is we would say this point we're going to call C1, C2, C3, C4, and we're going to say C1 equals A and Cn equals A plus, let's say, n minus 1 many delta x's. So to get to the second one, I add 1 delta x. To get to the third one, I add 2 delta x's. And then really, sort of in general, what I'm doing here is I'm adding up these boxes. So these boxes are base times height, so delta x times f of C1 plus delta x f of C2 plus delta x f of C3 plus delta x f of C4, right? And you could use summation or sigma notation. You could say the sum I equals 1 to 4 of delta x f ci, right? And if you wanted to sort of generalize, you could do this for whatever n you wanted, right? Delta x would change, the ci's would change, and so on. So this is nice sort of notation. Well, notice if the function is increasing, this left-handed sum is going to be an underestimate. Well, could you get an overestimate? Absolutely. How would you do that? Well, one nice way would be to go from 1 to 3 with what we call a right-handed Riemann sum. Let's just take the same sort of rectangular pieces, but at each piece, we'll just use the height at the right side of the rectangle. So, whereas here, you'd be having a little gap above your rectangles, here, you could say this is a right-hand Riemann sum. And I have 4 rectangles. And very creatively, we call that R4. The R being right hand and the 4 being 4 rectangles. Okay, so that's fair enough. But what we have here then is we would still define delta x the same way we did before, But then we could even use the same summation notation as long as C1 was equal to A plus delta x, right? And the regular generic Cn is equal to A plus n delta x. That'll get you the exact same pieces, exact same description, and you have a very efficient way of getting an overestimate. Now, you might say, why overestimate or underestimate? I want to estimate as closely as possible. In fact, maybe what would be best is to estimate with the midpoint of each of these wonderful rectangles. Well, that's been thought of too, and not so creatively. We call that the midpoint Riemann sum. And again, we use an m, and then if we want 4, we put in 4. I'm sort of tired of 4. Let's do 6. A midpoint Riemann sum with 6 means I've got to get 6 rectangles. So let's see. There's 3 more. And just to be clear, I'm going to take the height at the middle of each of these. Well, the widths are exactly the same as before, right? The widths of the rectangles, but where are the CI going to be? Well, we started with A, and then we went to A plus delta x. Well, down here, I just need Cn. Well, let me give you C1 to begin with. C1 needs to be A plus delta x over 2, right? So Cn needs to be A plus, and maybe there are a couple of different ways to write this, n delta x, the same as the right-hand Riemann sum, minus delta x over 2. That gets you into the middle of those. And you can use this exact same notation for summing it up. Of course, if you had 6, you'd put a 6.